Tanya. I'm an OpenSciEd teacher and facilitator. Today we're going to chat about Lesson 4 of the McKenna unit. I like this lesson a lot because it's a quick one-day lesson, but the students get a lot of information out of it. Before we jump in, let's take a second and figure out how we got to Lesson 4. In Lesson 3, we figured out that glucose, because it's much smaller, can fit through the holes of a small intestine. But that left us really wondering about what's happening to the food molecules that aren't being absorbed into the body through the small intestine. Let's look a little closer at the lesson at a glance. This is an investigation lesson that's about 1 day long. There's about 25 minutes of material prep in advance, but it is not a hands-on investigation, nor are devices required. When you look at this overview of this 1 day lesson, we can break it into 2 different sense-making chunks for our students. In the first chunk, we navigate in from Lesson 3, then we use the I2 strategy again to analyze more graham cracker data, but this time through the whole digestive system. We then have a whole group discussion where we figure out that complex carbohydrates reduce to 0 by the end of the digestive system in a healthy person, but McKenna, however, has remaining complex carbohydrates in her large intestine. We also notice that fiber never seems to change in a healthy person or McKenna, and this leaves us wondering with what happens to the fiber. This moves us into our second chunk where we analyze some poop data. Yep, poop for a healthy person. We realize that mostly water and fiber, which makes us ask, what does a fiber molecule look like that it actually comes out of our body as waste? We figure out that they are thousands of times larger than starch, and we update our progress trackers to identify what we figured out so far in Lesson 4. What we end up figuring out is a lot, even though this is only a 1 day lesson. We see that the food moves through a healthy digestive system, the molecules seem to disappear, and we think they might be getting absorbed like the glucose was. The fiber always stays the same in the digestive system and leaves the body as waste. And most other molecules are gone when they reach the large intestine in a healthy person. Only fiber and water remain. And McKenna's poop contains some additional food molecules, being glucose, starch, fatty acids as well, which are not found in a healthy person's. Let's slow down a little and dig deeper into those 3 key moments that we identified. The first key moment happens in part 3 during the building understanding discussion. During this discussion, you'll be using the I2 strategy again, which is what I see and what it means. This gives the students the opportunity to be able to look at the data and enough time to actually give them a moment to figure out what they think the data is telling them. For this discussion, you're being asked initially to focus in on the complex carbohydrates, meaning starch. And the students are able to see that in the mouth, McKenna's data pretty much matches a healthy person. But by the large intestine, a healthy person has no food molecules left, but McKenna has leftovers. However, we do figure out, though, the fiber seems to not change throughout all 3 of these graphs. This leads us to part 4, where we're actually examining the poop data. And this is a very quick section, maybe about 5 minutes total. But here the students are really able to confirm that the waste that comes out of the human body is mostly water and fiber with some other small molecules remaining. But that's it. This leads us to part 5. And this is another quick section, but important for the students' understanding of why the fiber leaves the body as waste. Here they see that the fiber looks like a lot of glucose and starch molecules put together, but it's thousands of times larger than glucose, and it leaves the body the same way as it enters the mouth. So where do we go from here? We know the large molecules can't get absorbed, but they still seem to be disappearing and aren't found in waste. At this point, your students are wondering if the large molecules are getting absorbed somewhere else in the digestive system, maybe in a different part of the large intestine, or they might actually be wondering if these large molecules are breaking down by chemical reactions. It's important to not confirm at this point whether a chemical reaction is happening or not, because this is something that they're going to investigate in a future lesson. Even though this is only a 1 day lesson, I still have some tips and tricks for you to make this go as smoothly as possible for you and your students. The first tip is to go slow with the data. Just like the first time your students looked at data like this, it'll take them some time to actually be able to understand what it's telling them. If your students are feeling really overwhelmed by the data, reinforce that they can focus in on just the carbohydrates and the fiber at this point. Next, your students are going to earn the word fiber, and this could be added to your word wall right next to the word glucose and starch from the previous lesson. Another word that is reinforced and your students might be using at this point is chemical reactions. But like I said before, if they haven't brought it up yet, that's okay. They'll get to it in a future lesson. In terms of poster management, pretty much the only thing that you're going to be referencing at this point is the word wall itself, and no real materials are created in this lesson that need to be revisited in future lessons. So now at this point, your students have figured out what's pretty much leaving the human body, but this gets them to think, I'm still wondering what's happening at the very beginning. So in lesson 5, you and your students are going to go back to where it all begins and figure out what happens when you actually eat a piece of food. Have a good day.